take them down and take them down and take them down. As you look, the whole room explodes. Take them down and take them down and take them. As you look, the whole room explodes.
When I was asked to speak about the challenging technological topic that we had to face at LivePerson at the last couple of years, I thought it would be interesting to share with you the challenges we had regarding data consistency in our service-oriented architecture, our new service-oriented architecture. So, if you build or you plan to build a service-oriented architecture, hope that what I'm going to share with you is going to help, that these ideas would come in handy. And in the next 30 minutes or so, I'm going to try to summarize the last couple of years' work, starting with the LivePerson architecture. I'll describe the service-oriented system that we built, go into details about data consistency problems in this environment, what we thought is a bad idea to do, and what we decided to do, and how Avro fits into this puzzle, and what we had to do on top of it. So before we begin, a couple of words about myself. I've been a developer, designer, architect, CTO for the last 25 years. I was the chief architect of a small company called Amihay that was acquired a couple of years ago by LivePerson. What was different for me at LivePerson is the sheer scale and in data and services. And this is a key factor of what I'm about to share with you today. So LivePerson is architecture looks like this. There's mainly 3 tiers. The first tier is the real-time tier is actually handling the world, handling web services and mobile applications and handling visitors. The second one is what we call the near real-time tier, is sitting behind the real-time tier and gets a lot of information from it, and usually does things like real-time reporting and analysis in many cases and stuff like that. The third tier is the offline tier, which collects the information and allows us to do reporting and analysis of in offline. So a very basic structure, but those 3 tiers are actually running multiple, like tens of different services, and are talking to one another all around. So when we built this system, we said that there's a basic rules for the architecture is, for instance, if I want to deploy a service, which it could be a cluster of multiple nodes, I would not like it to depend on other services. So there's a challenge in making it flexible. So now LivePerson is a pretty good company, big company. We have like 20 teams working on those things. We have changes all the time. And we realized that although we build a very, very strong basic, let's call it backbone, we have Kafka and Storm topologies running services on I want to save it in a data shop, and I want to data after 6 months, after a year. How can I make sense of data that in an agile world that things are changing? I'm writing data, I'm changing stuff, but the old data still needs to make sense. So those two questions were on our platter. We had the backbone, we knew how to move the data around, we knew how to move it between services, but how do we keep it consistent? How do we keep it consistent and we still be flexible? So the first thing we realized that we don't want to use direct APIs, or at least want to reduce the use of them as much as we can, because direct APIs produce a lot of coupling between services. So I'm a consumer, I want some information from another service. I would ask it for the service, I would need to know the API, I would need to know how to find it. But there might be tens of services that need this information from the producer. So now this producer needs to start thinking about a variation of the APIs now. Another thing is APIs, direct APIs, are by nature synchronous. And now we're talking about a distributed system with multiple services. By essence, it's asynchronous. Some of those services it makes sense to work with direct APIs, but only as their main flow, as their main single responsibility. But some of the times I don't need this main flow to be, it's not good for me as a consumer of information. This would add irrelevant complexity to the service, because, for example, if I have an interaction, one of the things we do at LivePerson is we do chats. So I have an interaction system. I'm responsible for connecting a couple of people, making the chat lines go between them. And I have also a dozen of services behind the scenes that does fraud analysis or sentiment analysis or just counting the number of lines. Now, as a chat service, I don't care, but those services care. And if they start pinging me and asking me questions, I would start to build mechanisms and systems for them. So it's like producing more complexities of the producer's services of the data and not focusing on the main task. So we thought it would be a bad idea to use those direct APIs, and we decided to go in another way. Mainly, use the message as the API. Use events, send data asynchronously, and this is the way to communicate between services. But it's not enough because, well, we do move the synchronous nature out of the picture, but we still need to control in some fashion the structure. So if I still need to know as a consumer how the data is structured and how it's going to be used. And so you need to define a contract. The contract becomes the message itself, the data itself, the structure becomes the contract between the producer and the consumers. So we decided to go with a unified event model, a unified schema. Every service in LivePerson is now reporting events in a very specific structure. And this structure is defined in one place. And this is a unified schema. It's not like a database schema that is like strict. It's built to be an evolvable mechanism that I can add my stuff onto it. But it's very important that we speak the same language. I want to add on top of it a bunch of management tools to manage this unified schema, because if I have like tens of teams working on this stuff, they would need to work on the same data. I would still need to make some manageability over it. I would like this mechanism to allow me to send the data over the wire. So if I'm generating a message or an event, it would be nice to have a system that would actually serialize it and send it over the wire. And since we also want it to be written for posterity, reading and writing data in Hadoop would also come in handy. And maybe the most important thing, I was talking about consistency but also talking about flexibility. So if I want to do, to make the services still flexible, I want to grow and change my data and change my schema in some fashion, I need to keep the data backward and forward compatible. And if I do that, an old consumer with an old schema, if the schema is backward compatible, would still be able to read my new stuff. Okay? So we're building a flexible system that allows us to make interchange between different services, and those services can consume the data in the way they know it by using maybe a different kind of a schema, but it should be backward and forward compatible. So I have a unified schema model, a single place where I define the stuff. It's evolving. I have management tools for ways to write it to the wire. I have ways to write it to the offline world, read and write it. And then I have a backward and forward compatibility mechanism. So if you dive into the event model itself, how would such an event would look like? So you go from the generic to the specific. Start with a common header. Every event in the system in the world would probably have something like a timestamp, or an event ID, or event type, and schema revision maybe. You can find those in your system. Then you can dive in a little bit deeper and say, okay, our system is working with specific entities. I know the stuff about them. For instance, in LivePerson, probably a lot of you, we have visitors on the website. So I know some stuff I want to keep about a visitor. I don't want every service to reinvent it. And I want this language to be consistent across services so I can do stuff with it. Then I would have add some more dynamic specific headers so I can have different metadata on top of an event. And it gets more and more specific till I get to the specific event body. So if it's a chat line, that would be the line itself. And a lot of the data would be encapsulated in the header. So if I'm reading this event, sometimes I don't really care about the chat line itself. I just care that this is an event and it came at a specific hour if I'm counting event, or it has a specific type and I want to know how much of those happened. So it allows layers of abstractions over the data model or the event model for the multi-services to use it in different fashions. And as a producer, I just keep the language. I don't care about how those events were generated at the producer. So this is where Apache Avro comes into the picture. Avro is a framework, a set of tools, if you will. It's a deserialization framework. It allows you to take a schema of data, define some data structure, and serialize it into bits. The Avro schema is JSON-based, and is actually supporting any structure of JSON that you can think of. So it's like a document. Our events look like documents. It has an Avro IDL language, which allows us to do the management part a little bit easier. We can define those schemas in a very, very easy fashion and control it in a single place. There's the Avro file with Hadoop support, so we can now use Avro for writing those events and reading those events in Hadoop. And there's the mechanism that calls Schema Resolution that allows me to take two schemas and convert between them. So I'm taking an event that was written with a specific schema and then reading it with that specific schema I have to, but then convert it to another schema. So Avro was created by Doug Cutting, a guy that you might have heard his name, responsible for projects like Lucene and Hadoop. So the credentials are pretty high, and he's pretty active. I've been having some chats with him over the user group, and is writing code himself, and is very, very reactive. So this project is really, really live and kicking. So if you know protobuf or thrift. Those are parallel technologies to Avro. The main differences between them is that they're more strict in their nature. They don't allow this schema resolution mechanisms, and they're less dynamic. Avro is dynamic by nature. I don't have to have the code compiled and work with it. I can do dynamic access to those binary streams I'm generating. Avro is also, especially when you're using Avro IDEAL, you can generate code. So if you're working with Java or C# or C++ or Python, you can generate the code that is actually defining the structures that you work with, and you work with it natively, and Avro would automatically allow you to serialize it and send it over the wire very, very easily. So it's called specific readers and writers. And we're using it, the Java version of it. So this is an example of an Avro schema. Well, it doesn't, let's say the truth, it doesn't look so good. There's a type record. The name of it is an event. There's a bunch of fields here, version ID, time, body, with types, string, long, strings, everything you can define here. It's kind of a JSON document definition. I can define an enum with those values, but it's not so readable. This is the Avro IDL. Now this is a little bit better. This is practically the main event that a LivePerson is using. This is really the thing I just copy-pasted from our schema definition. We have a common header. We have an array of participants. These are our logical entities that I just mentioned, like a visitor. We have a bunch of platform headers, which are a little bit more specific, are platforms that LivePerson is writing and are using for with cluster IDs and node IDs, the additional information of the technical information on the event. This is the Avro trick of saying it might be an auditing header, but there might be nothing here, so it's an optional field. And the event body itself. And every event in the LivePerson ecosystem is actually sent in this structure. And now, everybody that reads this event knows that this structure will be there. The event body would change. And there's some additional headers that might appear in some cases. And this thing is compiled into Java. And our developers are working with the code, the kind of a POJO DTO that is actually describing this structure. So they work natively in their own language. So, as I said, maybe the most important part in this system is making sure it's backward and forward compatible. Why? Because we have a multiple service system, and those services need to talk to one another, but I'm deploying a new service now. And this service change some data in the schema. And another service might be consuming this event, and well, there might be changes. So how does it work? So Avro has a mechanism called Schema Resolution. It can take two schemas, the writer schema, which it has to have it because the serialization mechanism of Avro is actually doesn't have the schema in it. So you're generating a bunch of bits. You send them over the wire, and you must have the schema to read them. Okay? But as a consumer, I can say, I don't know this schema, but I know that one. Please convert it. And Avro would do that if you follow a bunch of rules. And it's pretty simple. You don't have default values to your fields. Those default values would just fill in case the field is missing. You can add fields, of course, but and if you add a field to and the consumer doesn't know about this field, it just would not see it. The Avro would just ignore it. And field types cannot be changed. If you change a field type, you're screwed. Sorry. And enum symbols can always be added but not removed.
So you can never remove anything.
You can. The cost of removing something is the fact that you might not be able to read it again in the old data. So, so if we're talking about keeping a year and a half in a Hadoop and you want to read information that's old, you might want to use, you might not want to remove any fields. You can. It just, those are the rules that we decided to do. In enums, it's a little bit more complex because there's a bug in Avro implementation. They're actually using enum in Java, in the Java implementation. And enums in Java, even if you're adding a new enum, it would break. But we're working with Doug on fixing that. So, is this enough? Well, not quite. As I said, when you're writing Avro events, you need to have the schema to read it from. And Avro does have a protocol, an RPC protocol, that allows you to negotiate the schema between a client and a server, and then you can read the data that's being passed to you over the wire. But as I said, we don't want to use direct APIs. So what we decided to do is to write our own, it's actually an open source project called Migdalor. It's a client and server based on Zookeeper seated behind it, that actually keeps the schemas that we're sending in the LivePerson ecosystem. So we have a client that is sending the events. If actually every event is sent in LivePerson is sent through this client, and is actually making sure that a new schema would always get to this repository, so consumers. And I didn't say that we're working with Kafka and Storm on the near real-time tier. We have a bolt here that knows how to go to Migdalor and take the right schema to read it from. So again, the consumer might be using an old schema, a jar file that he's compiled with. The new schema would allow him to read the data and then convert it. The Avro would convert it for him to the old schema. And of course, also in the offline world, we do that. What else? Well, we realized that our legacy system also, we wanted to be part of this system, and the old system would send events in a totally different format that is not related to the new event model that we were writing. So what we did is we defined the old system events in the new system model in Avro, and we wrote a converter. And this converter is seated here, again, in the vault, in the Storm topologies, that allows the legacy system to send events to Kafka and to be read in as an Avro event by any consumer. So we added the legacy system, and yes, we have a legacy system to the party. We also added some auditing. This auditing editor I mentioned before allows us to look at the entire backbone and see if the events are streaming correctly, if all the data is arriving to the offline system. We've done it using this auditing editor that I showed you in the LP event. There's a bunch of other nice stuff. For instance, when you're using a unified schema and using Avro to do that, you get for free documentation, because everything is in one place. There's the schema is a JSON file, and there's a nice open source project called AvroDoc that allows you to represent it in a very nice fashion. So what we did is automatically, when building a new version of the schema, we just post this JSON to another server in our system and in our development environment, and just allow access to the data through this AvroDoc. It's a Node.js system. So the documents are always updated. You don't need to worry that someone will go and change an event and then go to a document and make sure that it's written there before, because he forgot or he didn't know that you need to do that. And it's, again, makes everything for a multi-service, multi-tenant, multi-team environment to be able to work together. And of course, we added a bunch of tests on top of the system to make sure that those rules of backward and forward compatibility are in place. So not by mistake, someone would add a field to the schema that would break it. So how good does it work? Well, it was up and running in November. It's actually a little bit before that. So the last Cyber Monday, we had 30 to 100,000 events per second running through Kafka and consumed by 7 Storm topologies. Right now we have in production about 10 Storm topologies running, and we plan to get to 15 by the end of the year. It was 2 terabytes of data saved to Hadoop. And this year we're going to get to, next Cyber Monday, we're going to get at least to double this number. And it's working. Data is consistent, we can read it, we can write it. We can deploy services without any trouble. We don't block, so deployment of a service doesn't block other deployment of other services. It's really nice. So, let me summarize. Use an event-driven system. Use as less direct APIs as you can. Create a unified schema for those events. Use Avro to do this implementation. And add some supporting architecture. Questions? Great, thank you.